This is part 3 of the exam prep videos in the lead up to the half-yearly exam for Year 9 Science coming up. I'm going to be covering the main important ideas, and I emphasize the important, for chapter 12. This is part of the chemistry topic. I'm going to try and make this video as interactive as I can, getting you involved. I really highly recommend you have a paper and pen at hand. This is going to help lots, okay? I'm going to go back to the very beginning with atom, concept of an atom. Now, atoms, they're the building blocks of matter. Okay, think of them as Lego pieces. There's about 118 that we know of in the universe. You don't need to know that. Okay, it's on the periodic table. You can just count them. But there's 118 different types of atoms, and they're typically made of three simpler parts. Okay, three subatomic particles. Sub means smaller than. Okay, smaller than the atom. Subatomic. PEN. That's the acronym I use. PEN. So I'll let you beat me to it. PEN is proton, positive charge. E is electron, negative charge. N is neutron, zero charge, neutral. Atoms. This is very important. The atoms that we encounter every single day, most of the time, are neutral. An atom, by definition, is a neutral entity. What does that mean? It's got a balance of plus and minus charges. Okay, plus and minus cancel out. Okay, I want you to have this this picture in your head of a seesaw. Think of plus 1, minus 1. Okay, even if you don't know how to do this without a calculator, you can use a calculator. 1 minus 1, you'll get 0, right? Because, so think of the plus 1 as plus, proton, minus 1 as minus, as an electron. They cancel out, okay? That's what 0 means, they cancel out. So let's take hydrogen. It's got 1 proton and 1 electron. They cancel out and they give you a neutral atom. What happens when atoms become charged? So if you rub atoms together, let's say, you form what are known as ions. You definitely need to know this. Ions, these are charged atoms. Just think of the O here as an electron, okay? A sphere with a minus charge, because it involves electrons, okay? Ions, they come in two main types, cations and anions. They're just names, okay? A cation is a positive ion, an anion is a negative ion. Cool, calm, and collected. C for cool, calm, and collected is what you need to know. Okay, when you're cool, calm, and collected, you're in high spirits, you're positive, right? Think of that. Now, cations, metals tend to form cations, and non-metals tend to form anions, or anions. I still don't know how to pronounce it to this day. I don't need to, but anyway. So metals want to lose electrons. To understand this, you need to do examples to see how it works. Non-metals tend to gain electrons. Let me show you. Let's do hydrogen. Let's do, for a metal, let's do sodium. So the way you draw an element is you draw the nucleus, you put Na for the nucleus, sodium, that's a symbol. 2 electrons in the first shell, if you recall. 8 in the next shell, maximum of 8, 2, 4, 6, 8. Okay, and the way you draw it is by pairing them up like this. And it's got 1 in the outer shell. Now, the goal of any atom is to have a full outer shell, be it metal or non-metal. That's their goal. If they have a full outer shell, they're stable. They're happy. They're stable, and they just sit there. That's what they want to do. They're lazy. Atoms are lazy, right? It's got 1 in the outer shell. It would rather lose that than gain 7 more, okay? Because it costs more energy, okay? It's better for it to lose that electron. It's just easier than to gain more, to carry more, bigger load, more luggage. When it loses that electron, so sodium is neutral. When it loses an electron, it now has an imbalance of charge. It's got more positives than negatives. It's got 1 more positive, 1 more proton than electrons, because it lost the electron. It's now got 10 electrons and 11 protons. So it's now charged overall, okay? Because 11 minus 10 is 1, plus 1. So sodium will form a plus 1 cation, okay? In chemistry, they put plus at the top. It's a superscript, plus 1. The plus means, so you read it right to left. it loses one electron to become positive overall. This goes for copper, for zinc, for any other metal we can think of. They'll have different valencies, but the idea is they'll all form a positive cation. So that's for metals. They will lose electrons to become positive. Non-metals, let's take chlorine. Okay, Cl for chlorine. That's the nucleus. It's got 2 electrons in the first shell, 8 in the next, and it's got 7 in the outermost shell. It's got 1 missing. Now, it would rather gain 1 than lose all the 7, right? It's much easier. When it gains 1, so being neutral initially, when it gains 1, it becomes negative overall, okay? So chlorine has 17 electrons. When it gains an extra electron, it's got now 18. It's still got 17 protons. The protons don't change. Protons stay the same. Okay, in chemical reactions, it's all about electrons. Outer shell electrons, I should mention. Valence electrons. 18 minus 17 is, I should say 17 minus 18 is minus 1. So the chlorine gains an electron, to become negative overall. Okay, when you have more electrons, you're more negative. If you have less electrons, you're less negative and you're more positive. So that's the idea. Just use your periodic table, go to your periodic table. You need to obviously know where the metals are and non-metals are, right? The metals tend to be towards the left and center. The non-metals tend to be towards the right on the periodic table. And just to note, the noble gases, the very last column, the very last group 18, they're inert, they're stable. They have a valency of 0. So they don't want to gain nor lose. They're happy as they are. Okay, they're noble. Think of them as noble royalty, noble people. Okay, so you definitely need to know how this works. Using examples, use your periodic table. Go to the periodic table and look up, let's say, I don't know, calcium. What would it rather do? Would it rather lose or gain? How many electrons? Something like that. So I'll give you some questions here to do. Go to your periodic table and determine whether or not the following will either gain or lose electrons. So let's say calcium, oxygen, iodine, xenon. Okay, pick up elements too. You can do things like strontium, and you'll notice a pattern. Okay, elements in the same group will tend to have the same valency, but anyway. I'll give you 8 to do. And students keep coming up to me and asking me this. This is very basic. We did this in the at the very beginning of the topic. The atomic number, what they tell you, the atomic number and the atomic mass. The atomic number tells you the number of protons or electrons. Okay. Atoms have the same number of protons and electrons. So hydrogen has an atomic number of 1. 1 proton, 1 electron. It makes sense because they cancel out and they give you a neutral atom. Helium, atomic number of 2, 2 protons, 2 electrons. That's the atomic number. Atomic mass tells you the number of protons and neutrons. Okay, because most of the mass of an atom comes from the protons and neutrons, the nucleus. Electrons do have mass, but they're negligible. It's a very tiny mass, so they tend to keep it out and say that the mass is 0. Most of the mass is from the protons and neutrons. So suppose I give you an atom that looks like this. And I ask you what element this is, count how many protons or electrons, and go to your periodic table, and you'll find out that it's helium. Okay, that's what the atomic number tells you. I want you to try this. Okay, so the zeros indicate neutrons, the positives indicate protons. Excuse my drawing. Okay, let's suppose I draw an atom like this, 4 protons, 4 electrons. Work out what the element is. Okay, practice with other elements too. But I'll stop here. So that's for chapter 12, and I'll continue with chapter 12 in the next video.